Hello, I am Kevin Ray E. Perez, and I'll be discussing how special relativity resolved the conflict between Newtonian mechanics and Maxwell's electromagnetic theory. The concepts under Newtonian mechanics are mainly based on ideas of Newton about motion, which correctly describes the state of motion of an object, whether at rest or moving in a straight path, and the forces that maintain and can cause changes in the body's state of motion.
It tells that the measure of the speed of light should depend on the motion of the observer.
Maxwell's electromagnetic theory, on the other hand, united all concepts of electricity and magnetism and had the findings that electric and magnetic fields spread as waves. Maxwell's observation proves that the value of calculated expression is equivalent to the speed of light, that is 3.0 times 10 to the 8 power meters per second, which implies that the speed of light must be constant. And that is where the conflict between Newtonian mechanics and Maxwell's theory starts. Try to consider a moving object of speed 1000 meters per second and place a source of light in it. Newton would say that the speed of the light coming from the source would be 1000 meters per second plus c, which contradicts Maxwell's theory, which says that the speed of light is a constant value. The theory of special relativity proposed by Einstein in 1905 explains that problems that involve motion of frames of reference at constant linear velocity with respect to one another and is based on two postulates. 1. The laws of physics are the same in all inertial frames of reference moving with constant velocity relative to one another. And 2. The speed of light is the same in all inertial frames of reference. The second postulate clearly tells that Maxwell's idea is correct. But does it mean Newtonian mechanics is wrong? Not totally. But the postulates of Einstein tells that Newtonian mechanics has limitations in terms of its application. If we consider moving objects with speed very small compared to the speed of light, Newtonian mechanics applies like the speeds of a flying ball and a running car. But if we consider speed that is close to the speed of light, a new concept must be included in order to supply the limit of Newtonian mechanics, and that is the Lorentz transformation, the counterpart of the Galilean transformation of the Newtonian mechanics.